Okay, so first of all, I have two types of functions. Questions 1 and 2 are the same type of function, just with some adjustments made to it. And then questions 3 and 4 are also the same type, again, with just some adjustments made to it. In the first one, it is x to the what power? Second, okay? So what we have to remember is the original parent function, kind of what that looks like on my graph. We even have a little guy up there on the cabinets that tells us what it looks like. That is a parabola. Y equals x squared is a parabola. And your parent function that we graphed back in the beginning of section 3.2 looked like that, or similar to that, okay? That's my sketch. Its vertex is at 0, 0, and it's symmetric on either side. You guys remember talking about that? Okay. And then the other one is y equals, what are we doing to x on the 3 and 4? Taking the square root, right? We also graphed the square root function back when we did all of the functions, and its original graph looks something like that. Okay, if you're not sure, if you can't remember, hopefully you still have your notes that you can refer back to as to what the graph should look like originally before it's made. Everybody ready? Okay, so let's take a look at number 1. Number 1 says f of x equals, in parentheses, x minus 1, and then squared. So I know my graph is going to be a parabola, right? So that narrows it down to 2 options. Which 2 options does it narrow it down to? Hold on, I can't move. There we go. It moves it down to which 2? Either A or C. Those are the only parabolas I have, right? Okay. Then what we have to do is determine what movement was made. I have a minus 1. The question is that minus 1 outside or inside of my function? It is inside. Okay. And so if I subtract 1 on the inside of my function, okay, how do I know it's inside? It is in the parentheses before I square. So if I do it inside of my function, it's going to be one of these things, either left or right. By subtracting it, it's going to go the opposite direction, which means it's going to go to the right one. Is that the only movement that I've made? Yes, that's the only change to my equation from the original. So that means it's going to take this graph right here and just shift it to the right one. Which option is that? C, right? Everybody agree? C? Okay. We're just matching. Mm-hmm.
So I got to write them?
What? Well, I mean, if that's up to you. It's your notes. It's what you need to study with. Right? Now, if I've already used if I already used C, does that kind of narrow down the choices for number 2? Yeah, but let's talk about the movement. With number 2, I have a negative x squared minus 1. So let's start with that minus 1. Is that minus 1 inside or outside of my function? Outside. So that's going to move it where? Down. So imagine this purple graph shifted down 1. Okay. But then what else does it have in front of it? What else does it have? It has a, what did I just highlight in blue? A negative, right? Is that negative outside of my function or inside of my function? Is it after I square or before I square? It's outside, right? There's no parentheses that are including it. So that means it's going to reflect on the x-axis, which basically just flips it upside down. So if I move down 1 and then I flip it upside down, it's approximately going to look like that, correct? Is that what A looks like? Which is the only other parabola there. So guess what the answer for 2 is? A. So do you kind of get what I'm doing is I'm looking at what changes happened in my equation, which graph moves that direction so that I can choose. On the homework, it's not just going to be 4 and 4. You're going to have like 12 different graphs to choose from and different equations. So it's not going to be as easy to narrow down. So we need to pay attention to what we're looking at so that we can then decide what happens to the graph. Okay, so I've used C and A. So obviously those are no longer going to be options. They are also not square root functions anyway, so we're not looking at those anymore. So now what we have to do is decide between C and D for number 3. This is now the square root function. What is this negative one? Is it inside my function or outside? Outside. So that's going to move it down 1. So imagine this move down 1. Okay. So like down 1. Like that. Right? I'm looking at 3 right now. And then what's in front of my function? A negative, which means that's going to reflect on the x-axis. So it just basically takes and flips it upside down. So I'm going to take this blue graph and flip it upside down. So which graph does that look like? B? Look at my graph. The purple is the original. The blue one is where I shifted it down 1. And then the red is where I took that blue one and I flipped it upside down. Does that make sense? Okay. Now, obviously, we know because of the negative in front of the square root sign.
So every time it's a negative in front, it's going to flip.
As long as it's not inside, yes. If it's outside, it's just going to flip upside down. Okay, if it's inside, that's when it turns like this, if that makes sense. Okay, the question, Destiny, I think I heard you say, is how do I know what the original looks like? Is back when we did 3.2, we took a day and we graphed a bunch of different functions.
Oh, we're talking about that.
Yeah, so that was for us to get familiar with what they look like. So you might have to refer back to those. Is everybody ready? Now, we obviously know that number 4 is going to be what?
C.
Don't call people idiots. But we've used A, we've used B, and we use C, so the only option is D. But let's talk about Y. Okay? And this one gets confusing. Anytime you have a reflection on the Y-axis where your graph turns sideways like this or kind of flips around, it can get confusing, and that's one of the last things we want to do. So let's start with the movement outside of my function. What did it do outside of my function? It went, what does that mean? The yellow, the negative 1 outside. It went where? Down 1. Okay, so I'm going to draw that. We're going to just color code each movement. And then, if I look under my function, inside my function, there is a 1 there. What kind of 1 is that? A positive. So if I have a positive number, that's going to move which direction? To the left 1. Okay, so imagine taking this and moving it to the left 1. Does that make a little bit of sense? Okay.
Yeah.
All right. Then we have the negative outside, which does what to the graph? It takes it and flips it upside down. So I'm going to take this blue one and I'm going to flip it upside down, which makes it like that, right?
Yeah.
But inside of my graph, or inside of my function, what do I have in front of that x? A negative. The negative inside takes it on the y-axis, so it reverses it. So basically what I want to do is I'm going to take this green thing and flip it this way. So then it's going to become like that. Does that make sense? So do you see how it matches what D is? This pink one is my final graph. What I did was I moved it down 1, then to the left 1, then I flipped it upside down, and then I rotated it on the y-axis. That's how I could tell my movements. But you got to kind of think of it one piece at a time. Is everybody good there? All right. So here's what we're doing next. I am going to give you a function, a parent function, one of your original graphs. Okay, in this case, it's the absolute value of x. What we're going to do is we are going to write the new equation with the shifts or the transformations that are described here. Okay, so take a minute and write that first part down. We'll move a couple of them together and I'll let you try some. I don't think so. As long as you know where everything goes to move it. You know, you have to know those. Our function that we are rewriting is y equals the absolute value of x. Depending upon what movements happen, that determines where I put the numbers. If I am moving up or down, I'm going to put the numbers behind the function, the absolute value of x. If I am moving left or right, those are going to go inside. If I'm reflecting on the x-axis, that goes in front of the absolute value. If I'm reflecting on the y, it goes inside the absolute value. And then if I am stretching or compressing, the number is basically going to go in front of the absolute value being multiplied. Everybody ready? All right, so first, we want to shift to the left 4 units. Is that going to be inside or outside? Inside, okay, so I'm going to go inside my absolute value bars. And if I'm going to the left, is that going to be a plus or a minus? Plus, okay, so it's, whoa. Yeah, it's always the opposite of the direction. Okay. What else does it want me to do? Move it up 3. Where is up? Inside or outside? Outside. Is it going to be a plus 3 or a minus 3? Are there any other transformations they want us to use? So that's my answer. Okay. I put the transformations that they described into the equation and wrote a new function. Everybody okay with that? Next one is reflected about the x-axis. You put a negative where? On the outside. So it's going to be y equals a negative absolute value of x. There is no other movement that they want, so that is my equation. Number 7, I want it to be compressed by a factor of 1/4. Okay, remember that number is just telling me whether it's a compression or a stretch. That number is going to get multiplied by my function. So it would be y equals, how do I multiply the absolute value of x times 1/4? How do I write that? Then what? 1/4 times the absolute value of x, right? That's where a stretch or compression goes. It goes in front of it. Is everybody okay with that? Okay, now before we move on, go ahead. So when you do a stretch or compression, it's just multiplied by your function. This is just so, because now it's telling me what it is. But like, remember yesterday we looked at the equation and we had to decide which way it moved. This is when I need to know that. I need to know it's going to be a stretch if that number in front of my function is bigger than 1, and it's a compression if it's smaller than 1. It is smaller. That's why it's a compression. Okay. Now, before we move on to the next 3 questions, I keep seeing people use the absolute value function when I change my function. So let's do a for example. Let's say I change my function to an x squared. If I'm talking about going to the left or to the right, inside of my function, I don't have absolute value bars to keep inside, but what I can use are what? Parentheses. So let's say I wanted to go to the left 3, okay? I would have to do parentheses. Left is inside and opposite of the sign. That's what I mean by inside of my function when you do a square or a cube or some power of x. Okay, there's no absolute value bars because that's not an absolute value function. If I wanted it outside, let's say I wanted to go up 3. I would do my x squared, and then after that, that's when I do the up 3. So to include something inside with a square or a cube, we're going to put parentheses. This one would be going to the left 3. Is everybody kind of okay with that?
one.
The bottom one, because it's after the x squared, that's going up 3. All right, same thing, new function. I want you to try these 3. This time we are writing the function y equals x to the 3rd power. You have 3 different transformations I want you to write the new equation to. One is shifted to the right 4 units. The other one is reflected about the x-axis and down 5 units. And then the last one is reflected about both the x and the y-axis. But remember, if there's no absolute value bars or square root signs, if you have an x squared or an x to the 3rd, you're going to need to use parentheses to do stuff that's in your function. Kind of like I did up here. I included it in, so I added parentheses and put my square on the outside. I'm saying don't use absolute value bars because this is not an absolute value function that we're writing. So to keep a movement like the inside movements left or right, we have to put parentheses around and then put the cube on the outside. Yes, that's right, because it's the opposite. Think about your number line. Your positive numbers are to the right. So if it's positive, you're going to go the opposite direction. When it's inside, it goes opposite. But other than that, you're good.
If this would be down, it would be a -2.
Yes.
Okay, so
Is it negative to the x to the 3rd minus 5?
That goes on the outside. On the outside. Well, okay, essentially. No, the first one says right 4 units. So it's not 3 or 4. That cube is not moving. Yes,
oh, so
I'm going to teach cardio. I did. But you were late. I'm sorry.
It can be reflected on the x.
All right. So let me see if I can clarify this. What is my function that I highlighted? Y equals what? X to the 3rd. So when I'm talking about movement to the left or to the right, that means I'm going to take x and I'm going to add or subtract a number before I raise it to the 3rd power. Okay, that's inside of my function. That's why we have to do parentheses, because we work parentheses first, right? So it would be x plus or minus something, close your parentheses, and then cubed. If I want to move it up or down, then it is my function x cubed, then plus or minus something. If I want to reflect it on the x-axis, my function is x to the 3rd. I just stick a what in front of it? Some cases, yes. All right. 4 right or 4 units to the right, inside or outside? Inside. So it's going to go y equals, but because it's inside, think about this. It's whatever I do to x before I cube it. And is it going to be plus 4 or minus 4? Minus 4. Okay. So I should have y equals, in parentheses, x minus 4, and then a cube on the outside. Does that make a little bit of sense? Okay. If, for number 9, I want to reflect it on the x-axis, that negative goes in front of my function, right? So it would be, there's a couple of different ways you can write it. If you're going to want to use parentheses, it's going to be a negative. Then your x to the third would be in parentheses. Okay? And then if I want it to go down 5, that is outside, and so it's going to be minus 5. However, in this case, those parentheses aren't really necessary. You can just write it like this. Does that make sense? If it's reflected on the x-axis, it just goes in front of my function. In this case, my function is x to the third. Now, if it is reflected on the y-axis, it has to go inside of my function. So it has to go in parentheses with the x before I cube it, if that makes any sense. Okay, so let me write you. So for this one, that's my x-axis, okay? For my y-axis, it would have to look like this. A negative x inside and then cubed. Do you see the difference? X-axis, y-axis. This could be an x to the third. This could be an x squared. It could be an x to the 10th. It doesn't matter. Outside is going to be x-axis, basically flipping it upside down. Inside, meaning before I raise it to that power, then that's going to be it. So what would the last one look like? Y equals?
Negative.
X.
No, parentheses. Negative.
No, wait, what you doing?
Parentheses. Third. Period.
Why is 2 negative?
Because.
Look, x and y, you have to put those together. Does that make sense? Is everybody kind of okay with that? Okay. So it's